Let ABC be an acute triangle with circumcircle omega and orthocenter H. Suppose the tangent to the circumcircle of triangle HBC at H intersects omega at points x and y, with HA equals 3, HX equals 2, and HY equals 6. The area of triangle ABC can be written as m root n, where m and n are positive integers, and n is not divisible by the square of any prime. Find m plus n. We have triangle ABC, which is an acute triangle with circumcircle omega and orthocenter H. And now we have the circumcircle of triangle HBC, and the tangent to that circumcircle at H intersects omega at points x and y. And we're given HA equals 3, HX equals 2, and HY equals 6. And we need to find the area of triangle ABC. So before we do anything else, the first thing we need to do here, if we see the words orthocenter and circumcircle, we need to reflect that orthocenter over BC. Then we get a point on the circumcircle of triangle ABC, which is omega. So the reflection of H over BC, let's call it point N. This is point N, and it lies on omega. And let's call point M the midpoint of HN, which lies on BC. The first thing we want to do is compute some lengths. We can do that by power of a point. We know that 3 times HN is equal to 2 times 6 by power of a point at H. So HN is equal to 2 times 6 over 3. 12 over 3, that's equal to 4. We can split it up as HM equals 2 and MN equals 2. So that's about as far as we can go inside circle omega. Now we have to work with the tangents. We know that the tangent to the circumcircle of triangle HBC at H, the circumcircle of triangle HBC is nothing but the circumcircle of triangle ABC reflected over BC. So if we take the tangent at point H, then the tangent to the circumcircle of ABC at point N, which is H reflected over BC, that tangent, which is something like this, is nothing but the reflection of XY over BC. So they're both going to intersect BC at the same point. Let's call that point T. There we go, that's point T. So now what can we do at point T? Well, we know it lies on BC, which is the line through the intersection points of the two circles, ABC and HBC. So we know that the power of point T with respect to each of the two circles are equal. We can use that. We know that the power of point T with respect to the circumcircle of HBC is Tn squared. But the power with respect to triangle ABC circumcircle omega, well, that's just Tx times Ty. So if we let Tx equal A, then Th and Tn are the same length and they're equal to A plus 2. So Tn squared is A plus 2 squared. It's Tx times Ty, which is A times A plus 8. And we have to solve this equation for A. We end up getting A squared plus 4A plus 4 equals A squared plus 8A. So 4A plus 4 is equal to 8A, and that means 4A is equal to 4, so A is equal to 1. And we can replace A with 1 and A plus 2 with 3. And this allows us to compute the length of Tm. It's equal to the square root of 3 squared minus 2 squared, which is the square root of 9 minus 4, and that's equal to root 5. So Tm, this entire thing here, is equal to root 5. We want to find the area of triangle ABC. Keep that in mind. But how do we find the area of triangle ABC? Well, it's just AM times BC over 2. So AM times BC over 2. Well, we know AM is 5, because it's AH plus HM, which is 3 plus 2, and that's 5. So we need 5 over 2 times BC. But if you notice, BC can be split up into two things, BM and MC. And if we let one of those segments be equal to C, little c, then the other one will have to be 10 over C, because the product is 10. That's the power of point M with respect to omega. It's MA times MN is equal to 5 times 2, which is 10. So that should also be equal to MB times MC. And that's why MB is equal to 10 over C. Okay, now we can express the power of point T in a different way. We know it's equal to 9, but that's also equal to, let me write it down here. 9 is equal to root 5 minus 10 over C times root 5 plus C. And when we expand this, it's equal to 5 minus 10 over C times C, which is 10, plus root 5C minus 10 root 5 over C. And that's equal to 9. So 9 is equal to negative 5 plus root 5 times C minus 10 over C. And if we delete the negative 5, we get that 14 is equal to root 5 times C minus 10 over C. So we have C minus 10 over C equals 14 over root 5 in the end. But we said we needed C plus 10 over C for BC, which would help us find the area of triangle ABC. Now, how can we get C plus 10 over C? Well, just square this. We get C minus 10 over C squared is equal to C squared plus 100 over C squared minus 2 times C times 10 over C. That's 2 times 10, so 20. On the other hand, C plus 10 over C, if you square, that's equal to C squared plus 100 over C squared plus 20. So it will be equal to 40 plus the square of C minus 10 over C. But we know C minus 10 over C. It's 14 over root 5. So it's 40 plus 196 over 5. This is equal to 196 plus 200 over 5, which is 396 over 5. And that's equal to C plus 10 over C squared. So C plus 10 over C is equal to 6 root 11 over root 5. And that is equal to BC. So 6 root 11 over root 5, if we substitute that in for BC and multiply it by 5 over 2 to find the area of triangle ABC, we get the area of triangle ABC is equal to 5 over 2 times 6 root 11 over root 5. Now 5 over 2 times 6 is equal to 15. So it's just 15 over root 5 times root 11. But 15 over root 5 is equal to 3 root 5. So it's just 3 over root 5 times root 11. And this is just 3 root 55. It can be written as m root n, where m and n are positive integers, and n is not divisible by the square of any prime. We can confirm that 55 equals 5 times 11 is not divisible by the square of any prime. Find m plus n. So that's 3 plus 55, which is equal to 58. And we are done. We just solved an AIME problem number 15. Thank you for watching this YouTube video, and please follow my channel if you would like to see more videos before the AIME 1 on February 1. Let's get to 400 followers before the AIME 1.